So, good afternoon or late afternoon. I hope you don't fall asleep, as I do nearly. I was flying in last night and I'm seriously jet-lagged, but maybe we can still do something here. So, BehavioSec is a Swedish company. We have been founded in 2007, and Sweden, north of Sweden, cold, dark, nobody wants to go out. So we came up with the idea, if we could identify people based on their behavior, which is officially a stupid idea. But after some years, we managed it, and we will see how we do it. So security is a kind of onion. So we started several years ago with usernames, passwords, and then they get stolen. And then we introduced IP blocks and firewalls and added MAC addresses, certificates, private keys, and we all kept the secret. Then lately we added device identity, which helped a lot in the mobile space. And then finally we get to the core. We get to the user. And the user is what we want to authenticate. We don't want to authenticate devices or machines or something like this. We want to have the user because we want to know if he is doing the transaction, if he is the one who really wants to do it. So we introduced biometrics, we all know this, but we heard a lot about frictionless, and we see this with our customers when they authenticate on desktops. They do their banking once a week, twice a week. With their mobile, they do it much more often. And I don't want to stand in the tube and say, I want to authenticate with my password. My password is my voice. So this is not the idea what we are doing. So we are authenticating users based on their behavior. And we do this when they do what they want to do, when they do their transaction, when they do their banking, when they do e-commerce or whatever. We do this by old technologies. So keystroke dynamics is there since the 60s. It's even there since World War II, when the people were authenticated based on their Morse codes, how they were really doing their radio transmissions. So we do traditional keystrokes on one side, but we used, as I said, it was cold in Sweden. We had another kind of mathematics we used for this. And so we do keystroke dynamics, and we do also mouse dynamics on desktops. And then we added for the mobile everything what was possible on the existing devices. So we take accelerometer, gyroscope, we take the swipes, how hard you press, we take it from how big the surface is you covering on the touch screen. We take the motion, how fast you swipe. We take even the hit zones in pin pads on which position of the individual key you're pressing it. And we take all these bits and pieces together. And from this, we generate a profile, a central profile, and collect the behavioral data of the user when he is doing what he is doing. And we take this data, analyze it in real time, and generate a score how well the user is fitting his own stored behavior. So the user is doing some transactions, 4 to 5 to 10, depending on how strong the authentication shall happen. And then when the user is coming back and the next time submitting a behavior, we generate a score how well he is fitting his own stored profile. So, and based on this, we give back the application a score between 0 and 100, how sure we are that he's the one he's claiming to be. So it can be a green, wonderful, he is the one. It can be a yellow or gray one here, so we are not sure, so let's see how he's behaving further in the transaction. So what we're doing this continuously from the beginning, username, password, we have some information. Then he's doing a money transfer. We have some information. He's doing maybe some more. So we do this continuously. And if we get a gray, maybe in the beginning, he might prove later that he's the one he's claiming to be. And if we get a red one, we would say, hey, well, I'm sorry, transaction failed, and please tell us more. So we have proven this in real time with real customers, a lot of them. Currently, more than 15 million users are using the technology. Whole Northern Europe is using it for banking purposes as well as for online payment systems. And this year we have already done a billion mobile transactions and are quite successful with our results. So what we're doing is that we don't do it, that we just capture the behavior. We captured it in a context. So when you're entering an amount or entering a username and a password, we store and compare this behavior in that context where it was captured. So the behavior of entering a credit card number is definitely different than entering usernames and passwords. So we join this together and bring it into context. On the other hand, we can do this on every device. We can do it on a traditional desktop, and we can do it on mobile devices. Any mobile device without additional hardware and without anything we have to tell the customer. So we don't have to teach him how to use the system. He's using his normal system and just doing the authentication just when he's doing his work. So as I said, we collect it in every app. We are on iOS. We are on desktop systems with one-time obfuscated JavaScript so that they are not so easy to capture and to take out and to reuse. And we do it also on every Android device. Here are some results, and the interesting point is we are nearly in the same league like traditional biometrics without additional work for the customer. So we can see just for a login, we have proved this with one of our customers who really gave us who really allowed us to share the results. Just for a login, we had 97% based on 20,000 users with 500,000 transactions. When we then add the transaction, we even go to 99 point something. And you would say, okay, 0.3%, that's a lot still. But if I was drunk yesterday and go back at 2 o'clock in the morning doing my banking, my behavior would not match, as you can imagine. But if I'm transferring just $100 to my mobile telco provider, the bank would say, okay, behavior is not matching. He has done this several times. I have seen this transaction. So it's a low-risk transaction. Just let it go. But if my friend yesterday was a really good friend and, okay, I transfer him $10,000, 2 o'clock in the night, my behavior would not match, and my microphone is working, the bank would say, this is a high-risk transaction, and the behavior is not matching. Maybe stop at this point, get back to the customer, raise it, and then confirm the transaction over with other means. And the interesting point is that between 5 and 7% of all transactions are high-risk transactions only. So this 0.3% even go down by a tenth. So the system is manageable with our customers, and they are quite happy with the fraud rates. So how do we do this? We capture in with a small SDK in the banking application when you enter a PIN or something like this. This is from Swish Payment in Sweden, where you just enter a six-digit PIN number to transfer up to €1,000 and send it to the bank, analyze it, and then flag the results. So under the hood, it's quite simple, as I said. It's a typical web server where we put in the JavaScript or where we collect the data from the mobile. We have an API. I heard that there are too many APIs today, but we have also an API. Sorry about this. And then we store it in any SQL database, might be also in NoSQL. We store it somewhere, the profiles, and update them over time so that we don't just have a fixed learning phase, we learn all the time when we have a transaction which is accepted and has a high confidence. We just train on the profile. So over time, the system is learning adapting to the changing behavior of the user. You all know this when you buy a new phone, you start typing slow and then get faster over time. And then we have a statistics server helping our customers tracking the transactions and getting back information about them. So setting it up in a web environment might take half an hour or 2 hours, depending on how fast you can type. You just include the JavaScript, set up the listener, and then you have to decide if you have just regular fields where you want to transfer the content also to the cloud or to your on-premises, or if you have a password which is security relevant, there you would have just an anonymous timing, so the system would only get information about the behavior and not the password itself. And send the data to the server and you're done. That's it. So you see, just put in the JavaScript, change it, add the fields, and in the submit it to the respective server. We can skip this. So, and this is how it looks like. Just clear from a JSON. We have key down, key up information, the keystroke, and at the bottom we have an anonymous one where we don't have the keystroke information on. So it's just zero. It's just indicating the position of the individual keystroke. So, as I said, it's quite simple. We have a web server pulling the JavaScript or having an application with the SDK in it. It's pushing the results to the web server, and then we have, on the other hand, the behavior to the behavior web server, and then the web server can fetch the information about how the transaction was going. So we are quite good in time, so we have a small demo, and then we can see how this is looking in real time in the dashboard, how we can really identify people. So it's just a typical money transaction, entering some data, and hopefully he is not too nervous, but he is also jet-lagged, so it might work. And then see, even with a jet lag, 99.96% in the session. I will try with my jet lag how I'm scoring. I'm the bad bastard with.
So basically, he's using my credentials now. It's quite simple. My password is my secret password. And the reason we're keeping it that simple is that it doesn't really matter about what you're actually typing, but rather how you're doing it.
The system is fully transparent.
So he's typing the same information like I did, just making sure that we're doing nothing strange here. Obviously, what is capturing is how long he hold down the key when the release goes to the next one, and comparing that to me, like say, in real time. So this is what the end user sees. Everything looks normal as well. But I mean, the real beauty is happening behind the scenes.
So, so my score was bad, but we see this now in the dashboard a little bit better.
Yeah, so this is what the bank
I'm sorry, I'm a bad fraudster. So my score is 0. This is not because of the jet lag. I'm really bad on him. So, and as we can see, we had the login. I was scoring quite well with 1%. The username is really bad, and the password is really. The system was trained, and the date of payment was my best one, 12%. This is quite well for today. And we can see really each individual field, how I'm scoring, and when you scroll up a little bit, here we can see.
My scores is pretty high in all my training.
So that's it. Not so much more to say to this.
And you can also see on the user level as well. I mean, obviously, this is a public demo, so we have a lot of users. This is live going on, as we see. But basically, you can see on my profile, you know, these kind of spikes is where you see the fraudsters come in.
Yeah.
I mean, I'm on the high 190s all the time. Okay. Whenever there is a fraudster come in, basically detect. So this is what you should look out for, like I say, in real time. Obviously, I have a lot of fraud because we do a lot of demos, but yeah.
Yes. On the other hand, on the mobile, we have much more possibilities than on the desktop. So we take the accelerometer, gyroscope, we take the pressure, location of press, and we fuse it at that moment when you're pressing the key. So in the moment you're pressing the A, we take these readings, we bring this all together, and transfer it to exactly the same backend to the server. So the data looks a little bit different. It's a little bit more. So we have a pressure, we have an accelerometer, gyro, and position of press. But it's the same JSON format, and you can build it yourself, as you can see. So architecture is exactly the same thing, except that we have an SDK in the mobile application using exactly the same backend. It looks a little bit different today, but maybe it's also jet-lagged, the presentation. So as I said, we piggyback it in a hidden field in the SSL channel and send it to the server where it's taken out, processed against the web service, and then the results are fed by push or by pull to the anti-fraud system. But we use this with any. We have a lot of interfaces, and if you have one we don't support, we would just build it. Post REST services, everything is available, and the service is quite easy. So we, if we have it on premises, we have some Java servers running against any SQL database, or we run it in the cloud in AWS. So calls, easy. What we have is we send it in some way the behavior together with a user identification. Might be something we don't, the system is, if it sees the first time a user, it just makes a new profile. So you just don't have to import users or something like this. Just start the system, let it gather data, and it will take care of it. So we send in a user ID, the behavior we saw, this is the JSON. We send in the time of the transaction, as well as a kind of session ID or something like this to identify it later and get information about the behavior of the user. Then we can also compare against other users. So we had in Sweden a case where some people were capable to get real Swedish ID cards, go to a bank, open an account, get a loan, and get lost. And as we are installed in the main, let's say, infrastructure provider, we were capable to find additional accounts used and opened by this fraudster. We have opened now our developer portal, so just get over to us and we hook you up, and you can instantly, as I showed you, instantly use the system and get it running. Yeah. Some screenshots from the developer portal. I think you saw enough APIs today. So the idea is really what we do is continuously. We start when the user is logging into and authenticate him throughout the whole session. On the other hand, what we can prevent is with this account takeover, we can prevent man-in-the-middle attacks, all these kind of things. And the other thing is it's low cost. It's transparent to the user. You don't have to teach him new tricks, and he can also just train the system by normally using it. So my time is nearly over. I hope I wake you up a little bit. At least I will not go to sleep so easily. So get to us and get hooked up if you're interested. It's quite easy to do.
Yeah, so we'll be out there. So please, welcome to a booth. Thank you.
Thanks a lot.